It's two girls. Okay, Srishti and Chandra. Okay, let us move. Let us move over here. Okay, so today what we are going to do, we are first going to understand. We will not directly go to questions. I want to solve some questions, but before that, I want to talk about something called as speed in transverse wave, which actually is always in your syllabus. Okay, so let us give the heading speed. That's what we are studying right now, speed of transverse wave, and then at the end we will do some questions. Okay, speed of transverse wave on a string. Okay, now this is one of the most beautiful topic which you will get over here. Okay, now how it is done, how it is understood, we will talk about that, and how do we write the equations or something like that, we'll also see that. Why don't, so let us define a string, a kind of a stretched string, right or not? Which kind of a string? Stretched, on which some kind of a wave has been formed. Okay, why I'm saying stretched? Because on a stretched string only I'll get some kind of a wave over there, right or not? This is some kind of a wave which is present on a string. Is that clear or not? And I want to understand what actually happens, or what is this speed which I should get it, or what can be the maximum speed that can be possible, right or not? See, so let us imagine first of all some of the important things related to this. Are you able to get me or not? So let's suppose if I want to talk about a string or any kind of a spring wave, you know that wave equation simply is given as we know earlier, y of xt is given as a sine omega t minus kx, or kx minus omega t. So we'll include conventional omega t minus kx. This is my particular condition of the means wave equation on any kind of a thread or something like that. Are you able to get me or not? See, so let us just define some of the quantities first of all. That, see, if this is a stretched string, which kind of a string? Stretched string. So it will have some tension in the string. The tension in the string, I'm writing it as capital T, got it? And then the mass per unit length of a string I'm defining. Why mass per unit length? Because we do not know how much mass will be present, how much basically the length is itself present. Okay, so we are defining the mass per unit length of the string, which is given as mu. Are you able to get me or not? Now, if I want to know how much is my speed or how much is the force present, then every bit of this thread has a different force, isn't it? And let's suppose if a wave is there, the wave is propagating with some kind of a velocity v. Are you able to get me or not? And I want to talk about this velocity v. Is that clear or not? So how to talk about that? Let us just see that. So if it is a stretched string or something like that, then consider, oh, 1 minute, let me just open that. Where is that? Yeah, so let us consider a very small element. Why a small element? Because for every another small element, the force is changing, isn't it? So I'm considering a very small element over here, and then I'll talk about this very small element, how to calculate the force or something like that. Now you see that, ध्यान से देखना बेटा, as I'm considering this small, very small particular arc over here, with the help of this arc, can I draw a circle over here or not? Tell me. I can draw a circle, isn't it? That's what is the concept of radius of curvature or not. Any kind of a arc can give us a radius. Are you able to get me? Yeah, so let's suppose if I drawn that circular arc over there, and that circular arc has some kind of a radius. I call this as radius r. I call this as what, guys? Radius r. Then you tell me, if it will have some, if this part of the region of the, or if this part of the wave has some kind of a velocity v towards right. Let's suppose if it has some kind of a velocity v, then there will be some kind of a radial acceleration which will be present over here or not. That will be exactly equal to v square by r. Is that clear? Are you able to get me? So we want to define, see, if the wave has some kind of a velocity, if wave have some velocity v, then at any point p, I can define at any point p, like over here, I can define my radial acceleration, that is equal to v square upon r, where r is the radius of selected, or radius of the arc, or radius of curvature, you can say. Is this clear? Is this clear or not? Okay. Now let us try to understand. Let us just understand how this happens, how anything happen. ठीक है ना? So what we will do, we'll try to zoom this. See this small length is creating some angle theta at the center of this arc. So we'll just zoom that out, and this is my particular case. 1 minute, sorry. Try to understand. Yeah. So I just want to zoom that out. When you will zoom it, you'll see that the thread is like this way, isn't it? Kind of a curvical arc over here. Are you able to get me or not? Got it. And this is my thread. I'm just zooming it. I'm not taking that whole thread. Remember that. I'm just taking that a small length DL part over here. Okay. So if I just take that a small length DL part, now look over here. You try to see when the person means, whatever is the particular arc over here, it will be stretched from this side by some kind of a tension T, and this side by some kind of a tension T or not. Yes, from both the sides there will be some kind of a tension, isn't it? है कि नहीं? अगर थ्रेड है, अगर थ्रेड को मान लो थ्रेड स्ट्रेट है, अगर मैं ऊपर खींचूं तो दोनों तरफ से टेंशन जनरेट होगा ना? There will be definitely generated. Some kind of a tension will be already generated, isn't it? So let's suppose these tensions are present. 1 minute. I'll just draw using the help of tangent, because these tensions are present always in which direction, guys? Tangent direction. In which direction? Tangent. Okay. And I'm considering some kind of a horizontal level over here. Got it or not? Is that clear? Okay. So let's suppose this is my tension T. This is my tension T. Now, this tension T will be creating some kind of angle theta with the particular horizontal level or not. Yes. Now, if it is theta, you try to say that angle theta will automatically match with this angle theta and theta or not. Do I need to prove it? Yeah, you can basically see that, means there is no need of proving that. You try to see this is my radius and this is my tangent, isn't it? And this angle is theta. The radius and tangent makes 90 degree. So this is 90 minus, if this is 90, if that angle is 90 almost. So I'm considering this angle to be almost theta. Are you able to get me or not? I'm not considering to be something like 90 minus theta. Is that clear or not? I'm taking a small angle approximation. Are you able to get me or not? Okay, so now look over here. If I resolve this, we have two components of tension. One of this side, isn't it? One downward for each. Let's try to see that. This tension T has two components. Similarly, this tension T has also two components. One is T cos theta. This is also T cos theta. Jaldi jaldi likhte hain. This is G sin theta, T sin theta. What do you observe? That 2T sin theta is present in downward direction or not? How much is present? 2T sin theta. And tell me, this 2T sin theta is only, means if I am an observer sitting on this string, what I am? Observer sitting on this string, then I'll feel a centrifugal force outside or not? Yeah, I'll feel a centrifugal force outside, isn't it? And that centrifugal force will be whatever is my mass. I call it my mass to be dm. Okay, let's suppose this string has a mass dm. So I'll feel a centrifugal force dm into radial acceleration ar outside or not. Are you able to get me? And since this thread is not breaking at that instant of time, then this 2t sine theta, must be equal to dm into radial acceleration. Yeah, are you able to get me or not? Is that clear? Now, if I know my mass per unit length, if I know my mu, so basically mu is equal to a small mass by a small length if radius of curvature is r and this angle is whole twice theta. So can I just write over here, if this is 2 theta, so dm by arc length will be how much? R into 2 theta. So this implies dm also equal to how much? Mu into, sorry, 1 minute, dm. Huh? Didn't I have taught density linear? What is this? Mass per unit length is my linear mass density or not? So linear mass density is equal to chota mass by total length or not? How much is that? R into twice theta. Are you able to get me or not? So this implies dm is equal to twice r mu theta. Are you able to get me or not? Is this clear? So basically this is what is my mass. This is what's my force equation. I'll just replace all these things. Okay. So try to see 2t sine theta, which is equal to mass m dm into radial acceleration ar, and where dm is equal to mu into r into 2 theta. This is my mass per unit length density into length over there, arc length over there. Okay, replace it over here beta. What you will get, 2t sine theta is equal to dm mu r into 2 theta radial acceleration. If you see radial acceleration, that is also v square by r. How much is that? V square by r. So r got cancelled, 2 got cancelled. And if theta is small, sine theta can be written as theta or not. So the equation, this also get theta and theta got cancelled. And we got one of the finest equation, that velocity of wave at any instant of time is defined as root under tension by mass per unit length of the thread. What is that? Tension T by mass per unit length of the thread. Are you able to get me or not? And this is called as speed of the transverse wave on a stretched string. What it is? Speed of a transverse wave on the stretched string. Are you able to get me or not? Is this clear? मजा आया? Easy peasy. ठीक, तो मैं एक क्वेश्चन दूंगा, मींस okay, let us have some points related to that. It's not only about the question. First of all, this calculation is based upon a small angle approximation in which we say that sine theta will be almost similar to my theta. Is that clear or not? This calculation is totally based upon what? A small angle approximation, where I am considering sine theta to be similar to theta, and almost this angle and the angle made by tangent with horizontal to be also equal to how much? Theta. Are you able to get me or not? So there are two approximations which we have taken, and that provides us the correct answers, isn't it? Okay. Can we move ahead? Okay. So let us move to some good questions. Let us just try to see. Okay. Try to write one question. What it is saying? A transverse wave is given by equation. A transverse wave is there, which is provided by a equation y is equal to 0.02 sine 1.0 meter inverse x plus 30 per second into time t. This is the transverse wave equation, okay, which is propagating on a 1.0. It is a transverse, this is the transverse wave equation which is traveling on a stretched string, where the mass per unit length of the string is given, and that is given as 1.2 into 10 to the power of minus 4 kg per meter. Okay. Then the question is find the tension in the string. Find the tension in string. Tell me fast. Tell me fast. A transverse wave which is following this equation, you have to tell me find what is the tension in the string. Chandra, are you able to understand? This is one of the finest questions. Do it fast. Any answers? Answers. Can you tell me within root or something like that? You have to square it. Yes, at the end. Yeah, that's a good thing. Here, transverse wave is given, isn't it? So this is my wave equation. As you know that the wave equation is given as y is equal to a sine kx minus omega t. Let's suppose if I'm yeah. So this is basically a right going wave. Which going wave? Right going wave, isn't it? If I write in original form. So if I write y is equal to a sine kx plus omega t, that means the wave is going towards left. Where it is going? Are you able to get me or not? Yeah, we are not following the conventional equation, isn't it? Okay. Now look over here. If you see this, here also here are two terms. One is kx and one is omega t over here or not. So if I know the wave equation, if I know the transverse wave equation, then the velocity of wave is yeah, that is what it is. It is how much? Omega by k. Omega is 30, k is 1. So velocity of wave is 30 meter per second. And I know that uh, velocity of wave is given as root over tensor in the state t by mu, isn't it? Where t is the tensor in the stress stream. Uh, it will be a square. It will be a square. So v square, which is 900 into 1.2 into 10 to the power of minus 4. If you will calculate it, I think 9 to the 108, 12 9 the 108, 00, yeah. Yeah. Because if I just send the square root over there, it will become a square. Okay. Hmm. Can we move ahead? Mhm. Okay. Now look over here. Let's do one more question. Okay. I think this is perfect now. So did you got that idea or not? That whenever we have a wave equation, we can have the velocity of wave easily. Whenever you have the wave equation, you can have the velocity of wave easily. And if you know the velocity of wave, then you can just put in the stretched string case and you will get the net value of tensor. Are you able to get me or not? So there can be many questions, but I want to ask a very good question. There is a truck which is moving. I am a fan of this question. Yeah, I learned it from Nitin Vijay sir, who is my motivation and whom, yes, yeah, he is my physics teacher. Okay, and I love him like hell. Okay, so try to see. The question is, what they are saying is simple and logical. They are saying that there is a string attached in this truck, okay, and there is a string which is attached. Basically, this is a tight string, okay, having tension is equal to 100 newtons. This is a very tight string having a tension of 100 newtons, and the linear mass density of the string is also provided to you, and that is exactly equal to 0.25 kg per meter. Okay, the question is simple. Let's suppose if this wave which was generated has been traveling towards right initially, then find the velocity of the particular truck, find the velocity of the truck, so that the find question is find velocity of truck so that pulse remains stationary with respect to ground. Yay! Stationary with respect to ground. Mhm. Yeah, it's simple. I am saying it's simple, that means it's totally simple. Yeah, we can do that. It's totally easy. Think, just think. Put your brain out over there. It's a, what do you mean pulse remains steady? That's what you have to find. What's the meaning of that? That's why I have given you the question. I want this wave to be felt as a stationary with respect to ground. Acha, does this truck has an acceleration? No, na. So no pseudo force is appearing on the string, isn't it? Acha, try to understand. Yeah. Hmm. The truck has to move with the same velocity in the opposite direction. Very, very good, Chandra. This is a nice answer. Okay, so look over here. Try to see. Is it coming 20? Let me check. The velocity of, first of all, the velocity of pulse will be how much? Root under T by, isn't it? So the tension is provided to you, isn't it? Tension is given 100, mu is given 0.25. So 0, 0. So that becomes how much? Root under 24, 400 almost. So that is 20 meter per second, isn't it? Now that 20 meter per second is in along which direction? X direction. Which direction? X. So try to see. I think you guys have calculated till means इतना दूर तक समझ में आ रहा है ना? Now the point is I want this pulse with respect to ground. Basically I have to calculate the velocity of pulse with respect to ground or not. Yeah. So here ground is there, truck is there, pulse is there. The three constants are appearing. So first, if I want to write velocity of pulse with respect to ground, then I have to take velocity of pulse with respect to truck first of all, and then velocity of truck with respect to ground. Are you able to get me or not? Why do we add it? I think I have derived that relation for you. That relative velocity relation. Relative. No, 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 no. I think that's totally different thing which I'm talking about. Okay, I'll tell you how to do it. Let us understand that. First of all, that used to be negative due to some reason. Look over here. What is negative? Let us see that. Okay, I think Do you remember that inertial and non-inertial frame of accelerations case? Huh. So same thing is happening. This is my truck which is moving at some kind of velocity v, and this is my observer or a ground which is at rest. Now there is a particle inside the truck which is also moving. Are you able to get me or not? So there will be how many frames? 3 frames. Try to see. So this is my particle over here, and I want to define velocity of particle. This is my truck observer T, and this is my ground observer G. So you know that I can write this relation that according to vector form, velocity of particle with respect to this vector means ground. Okay, 1 minute, T and G. So we know that if I want to write this vector relation, velocity of particle with respect to ground, then that must be equal to the sum of other two vectors, velocity of particle with respect to truck plus velocity of truck with respect to ground. Is that clear or not? So the basically if you can see it, you can write it perfectly. Okay, they are forming the vector pairs. Okay, particle with respect to truck with respect to ground must be equal to velocity of particle with respect to ground. They're creating some kind of a closed loop over here, isn't it? Are you able to get me? So the most basically what we write as negative is, you see that velocity of particle with respect to truck, we write it as negative. Velocity of particle with respect to ground minus velocity of truck with respect to ground. Now you got the idea. You write their relative velocity, this and this relative velocity. You do not write this and this relative velocity. Did you got the idea or not? Okay, so you always follow this rule. Now, when you will see that velocity of particle with respect to ground is how much, pulse with respect to ground, I have to find it 0, because that is what the question is asking. Find the velocity of pulse. Yes, no? What is the question? It's saying pulse should remain stationary with respect to ground. So velocity of pulse with respect to ground should be 0. Velocity of pulse with respect to truck, we calculated it. It's 20 I cap, and that should be velocity of truck with respect to ground. You calculated it. Velocity of truck with respect to ground should be how much? Minus 20 meter per second. Understood it? Chandra, did you got the idea or not? First of all, remember that whenever we are writing the relative velocity equation, like let's suppose if I write velocity of A with respect to B, then I write V of A minus V of B, isn't it? That is totally different thing. Basically these are two things happening in the same frame. Means these things must be measured with the same frame. Like if it is ground, it should be ground. If it is truck, it should be truck. Are you able to get me or not? Okay, minus sign should be accompanied these measurements. The measurement of A and B must be done through same frame. Yeah. What I wrote basically, you can write it directly this also. This relation, according to you guys, you will write this as velocity of pulse with respect to truck, isn't it? So you will get the equation velocity of pulse with respect to ground minus velocity of truck with respect to ground. Then you send it over there. But I follow this rule, means writing the relative rule, means velocity of pulse with respect to ground. If I calculating it, it must be the sum of velocity of pulse with respect to truck and velocity of pulse with respect to ground. Are you able to get me on it? I follow this vector method properly. I try to solve everything using vectors. That gives a clear insight. Okay, है ना? समझ में आ रही है बातें? ठीक, चलो आगे बढ़े. ओके, लेट्स सॉल्व वन मोर क्वेश्चन. बोल रहा है अच्छा क्वेश्चन है, रियली मजा आया क्वेश्चन बनाने में. तो जल्दी जल्दी करते हैं. ओके, बिकॉज आई हैव टू डू सम मोर. ओके, देयर इज अ पुली अटैच्ड ओवर हियर. Okay. And why everyone fears from me? Chandra, in the class also it happens now. Arey, sir, certainly a very good question, isn't it? Everyone is confused how to do it. Isn't Chandra? Hello? Almost 90% of the guys are like dead after hearing a new question once again. So I am attaching a rubber stick. Which kind of a stick? A rubber stick over here in such a way that it is fixed on a ground. How it is? It is fixed on a ground. This is mass M, this is A, and this is B. Okay. The point is, बोल रहा है, this is a rubber tube and the length of this rubber tube is given to you. It is 12.0 meter long. Got it? It's 12.0 meter long. Uh, and the mass of this rubber tube is given to you. Rubber tube mass is also given. It is 0.9 kg. Got it? बोल रहा है कि if the mass of the block is 5 kg, if the mass of the block is 5 kg, then means I'm just doing one thing. I'm just hitting this tube. I'm just hitting this tube over here. Got it or not? At the end, it's stuck over here at the end. Then find how much time it takes, time taken by the pulse to go from, find the time taken by the pulse to go from point A to point B. Tell me fast. What will be that? Easy peasy. Too much easy. Sir, by analogy, can we prove it for solids and gases as well, like root under gamma by rho? Like the bulk modulus follows a different kind of a wave. Basically, it's a pressure wave which it follows. So, like we can prove it, but it will take if we go through the pulse wave equation. That's a very good thing then. Like pressure wave equation. Sorry. Okay. So in pressure wave equation, it can be automatically proved. There is. अच्छा एक बात बताओ. You tell me. No, 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 means this. Why you are getting panicked? This rubber band I told you, this is fixed over here. So the masses are not moving at all. Is they are moving, guys? No, no. Yeah. So if it is fixed, then the condition is same, simple. No, 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 no constant relation. Constant relation only appears when the pulleys are moving. Okay. So this is my mass M. Mass of the block is how much? 5 kg. So the downward weight will be how much? 5g, isn't it? है ना? Srishti? And that will be balanced by my tension T, isn't it? If this is fixed, then we know that a same tension T will be up here. Yeah. So If this is fixed to t is equal to how much? 5g, which is 15 Newton. Are you able to get me or not? Yeah. So the rubber band is fixed over here, na? So does its weight matters? No, no. Yeah. So this is not moving. So the tension along both the threads will be same, and that will be balanced with the mass which is hanging over here, which is equal to 5g. Are you able to get me or not? Okay. Chandra, did you got it? Let us see. Now, let me check. I think so. This point will also have same tension, isn't it? So if the tension is same, so can we find the velocity of the wave or not? Velocity of the wave is what? Root under t by mu, isn't it? Correct now? अच्छा tension कितना है बेटा? 50. Mu is what? Here mu is not given. Mass and length is given. Mass is how much? 0.9. Okay, 0.9. Uh, let us make it 0.1 now. Let us make it 1 kg. Why to make it 0.9? It will be so difficult to calculate, isn't it? So let us call it 1 kg. Mass by length is 12 meter, isn't it? So if you send it upwards, you'll get velocity of wave something root under 50 into 12. ठीक है? So that is my velocity of wave. So time taken by wave go from point A to wave B is what? Distance, which is 12 divided by velocity of wave. Are you able to get me or not? That's going to be my answer. Is that clear? So how much is that? Root under 12 by velocity of wave is almost, how much is that? Oh, sorry. Uh, 12 by root under 50 into root 12. So I think you'll get it as root under 12 by 50. So इसको solve कर लो ना यार. मैं solve करूँ क्या? नहीं ना. तो solve कर लेना, okay? ठीक है ना? चलो, can we move to next question? ओके अच्छा एक एक क्वेश्चन बहुत अच्छा आता है ना मतलब ये क्वेश्चन वन ऑफ द मोस्ट इंपॉर्टेंट क्वेश्चंस में माना जाता है ना एंड आई विल डू दैट डेरिवेशन फर्स्ट राइट नाउ एंड दैट इज कॉल्ड एज यू गिव द हेडिंग derivation for hanging rope. Yeah. Okay, can I move ahead? डेरिवेशन ऑफ हैंगिंग रोप ये बहुत ही अच्छा है कॉन्सेप्ट समझना अच्छे से है ना इट्स गोइंग टू दिमाग हिला देगा ठीक अब ध्यान से देखना जरा लुक ओवर हियर आई हैव अ हैंगिंग रोप फ्रॉम अ वर्टिकल वॉल ठीक है ना सॉरी हॉरिजॉन्टल वॉल I just took a rope and I hanged it vertical word or not okay what I made is I just did one thing I just means I'm saying that this is a heavy rope of mass m and length l. Got it? This is a heavy rope of mass m and length l, and a transverse wave is generated at the bottom. Look over the question. Okay, transverse wave is generated at the bottom. Okay, the point is simple. The question is find the time. Find the time. First case is if the transverse wave is generated at the bottom, then find the time taken by wave to reach top. To reach top most point. Do it. Do it fast. Yeah. Aksa liar. So first of all, thank you for the elegant proof of wave velocity. I'm also thanking you to watch this video. And yes, we can prove it, but we will require the pressure wave equation. Pressure wave equation gives the perfect analogy to understand about the waves in the cases of solids and gases. Okay. So of course you will get that, but the pressure wave, you have to use the pressure wave equation. We are using this technique only for the case of string waves, because in the pressure wave we will not be able to get that particular kind of a radial velocity or something like that. So that becomes a different case in terms of solids and gases. Wow, I got some comments on YouTube. Do it fast. Please do it fast. Can't you understand? Guys, do it fast. What is the answer? Hello? 1 by 1 by 0. No, it's not correct. Think here. अच्छा एक बात बताओ. Is tension is constant over here or variable? Hmm. Yeah. Now you got the ideas. So tension is not a constant over. If it is a vertical row, if it, I have told you guys many times, if it has a mass, listen to the question. So you see that this is the heavy rope which has a mass, which has a length. So that means that there will be a variable tension. Okay. So let us just consider the task is simple and elegant. Consider an element, a small element dx. ऐसे ही करते हैं ना. dy वर्टिकल है तो बहुत लोग ऐसे बोलते हैं बेटा dy मान ले. क्या मान ले? dy located at distance y from the base. ठीक, इसकी लेंथ कितनी मान ले? dy. Is that clear or not? Are you able to get me? Now you see that when I want to find the tension over here, so basically the tension will be present due to the mass which is hanging. Oh, sorry. The tension over here will be present due to the hanging mass which is vertically present over here or not in the downward region. So we know that how to find that mass. Let us call this mass to be m dash. What is that? M dash. So the tension T, the small tension T which is present for this region, T dash, since this is a vertical rope, so T will be, or T dash will be, I'm not finding the total tension, I'm just finding the small tension. T dash will be M dash Z, isn't it? What is M dash? So we know that lambda is equal to bada mass by bada length is equal to chota mass M dash by chota length Y. यही है ना रिलेशन. वर्क एनर्जी पावर में इसको जाके अगर किसी को देखना हो तो देख लेना है ना. So m dash z, which is equal to m by l into y into gravity g. ये मेरा क्या हो गया बेटा? टेंशन. अच्छा जो वेलोसिटी होगा, वेलोसिटी विल बी इक्वल टू रूट अंडर टी डैश बाई म्यू. यही होगा ना? अरे कुछ तो बोलो हाँ या ना. तो टी डैश है कितना? m by l into y. What? There was. We'll come on that. We'll come on that. Still, it's not over yet. I'm coming on that. So T dash is m by L into length y into gravity c. Now the second point is mu. What is mu? Mu is also mass by length or not? Yes. So look over here, this and this got cancelled and this velocity is equal to root under yg. You see that this velocity is what? Variable. कैसी है velocity? Means यहाँ पर velocity 0 है. prove here the velocity is 0 because y is 0. As the y is increasing, velocity is becoming maximum. So that means time will be also variable. Are you able to get me or not? So if velocity is variable and time is variable, then we know that basically velocity will be given as dy by dt, isn't it? That should be equal to root under yz. So dy by root under y is equal to g dt. And if I integrate it, then I'll get the total time of traveling or not. Understood? Is that clear or not? So look over here. This is what written as integral y to the power of minus 1 by 2 dy, and g dt is means I want to find total time. So 0 to t. Oh, sorry, use a small t. So gt at 0 when time is 0. Look over there. The velocity is also 0 or not, and y is also 0. So this is taken from 0 to length L. Are you able to get me or not? So if I do that integration, what I'm going to get is y to the power of minus 1 by 2 is y to the power of minus 1 by 2 plus 1 minus 1 by 2 plus 1, and the integration from 0 to L is equal to gt. So if you do it, you'll get that time is actually becoming equal to 2 root under L by g. What it will appear as? Root over L by g. Is that clear? I think I missed something here. Root g will appear. See that? Why root g is there, no? So that is why it will be 2 root under L by g. Is that clear or not? Did you got the idea? Understood? अच्छा. अब एक सिंपल सी बात है. This is the case when we are generating the wave at the bottommost point. When we are generating the wave at the bottommost point, the time I am getting is how much? 2 root under L by g. Are you able to get me or not? Similarly, if I generate the wave at the topmost point, the time taken to reach the wave to this ekdam lowest point is also same, which is 2 root under L by g. My question is, let's suppose if this time I am generating two waves at the same instant of time, one at the bottom, one at the top, right or not? Are you able to get me or not? So in the same question, the question is same. If the transverse wave, if the T wave is generated simultaneously at both top and bottom, then find the time then find the time when both waves will meet each other. Will meet each other. Then find the time when both waves are going to meet each other. Got it? I have the string. Yeah, that's a very nice question which I have asked to you. It's not easier to solve. Think and then reply. Okay. मतलब आसान ही है, ज्यादा हार्ड नहीं है. ध्यान से सोचोगे तो बन जाएगा. मतलब एक दो तीन, बस ऐसे 3 सेकंड में बनेगा. ध्यान से सोचोगे तो. बोल रहा है आई हैव अ हैवी rope of mass m. Already this was question done. So I have a rope of mass m and length L, isn't it? Heavy rope है. Then you have to find if I generate a wave at the downmost point and if I generate a transverse at the topmost point at the same instant of time, then you find that at what time both the waves will meet each other, isn't it? Do it. So to find the time when they will meet each other, the first task is to find the distance where they are going to meet each other or not. Let's suppose if the distance is, yeah, basically if I know the distance, then I know the speed or not. Whatever you do, the velocity of wave, like just like the previous question, this is just like a previous question or not. Whatever you do, the velocity of wave which will be generated in this hanging row is exactly equal to how much? Sorry, let me erase this variable first of all. Is exactly equal to v is equal to root under yz, isn't it? This is the variable velocity which we got earlier, right now, just before this question, isn't it? Now, if this is my velocity of both the waves, whatever I generate, I told you earlier also, if I just make the wave to be generated at the bottom, time taken by it to go at the topmost point is two root L by Z. Similarly, if I generate a wave at the top, then the time taken by the wave to reach this bottom is also 2 root under L by Z. My question is same. I generate this wave at the same instant of time. Velocity will follow the same equation, which is root under yz. Then you find the length first of all, where this particular what will meet, the waves will meet, and then you can find the time easily, isn't it? Are you able to get me? Hmm. So do it. Hmm. अच्छा एक बात बताओ, both the waves are following means one wave is going down, isn't it? Another one wave is going up. Both the waves are following same velocity equation, isn't it? Hannah, Srishti and Chandra, both. Are you able to get me? Okay. Now, if let us consider the first case for the bottom one. For bottom, no. For bottom one, you are proceeding it perfect, but there is slight mistake in that particular thing. Okay, check that. Okay. So for the bottom wave which is getting produced, the velocity equation is still same, root under yg. अच्छा एक बात बताओ बेटा, I want this y first of all, ना? I want this y. So I must integrate from 0 to y. So dy by dt root under yz. Are you able to get me or not? So that means, let me just divide this two parts of calculation. So that means, what will be this equation? Dy by root y, isn't it? Dy by root y to g dt, root g dt. Okay. And if I do the integration, I'll get the relation or not. The integration must be taken from 0 to y, and if I reach this point at time t, at what time I'm reaching? T. So 0 to t, the integration should be time, the integration for time should be also from 0 to t. Are you able to get me or not? See, the wave which I am generating at this down point and top point are going to meet after some time, and they are going to meet at some length, but the velocity which they are following are same. So I can apply the same velocity equation, and which is variable, and integrate to get the particular equations of length and time, void or not, and that's what we are doing. So if you integrate it, it's once again that same integration, you will get it. I'm writing it directly. It is 2 root y t is equal to root g t, and the time taken by the wave to go from the bottom to this point is how much? 2 root under y by z. Is that clear or not? Are you able to get me? Root under y by z. Is that clear? First part is clear, Chandra. Is this clear for you? Okay, now I'll do the calculation for the now top wave, for top wave. Now look over here, the top wave is coming down, so its velocity will be negative. Now the biggest mistake what the people do is they do not consider the negative sign. Okay, so this is minus root under y by g. Okay, no, it will not be cancelled out, you see that. So minus, 1 minute, I'll write it as, So that is equal to minus v is equal to root under yg. Okay, and minus v is minus dy by dt. So I'll write minus dy by root y is equal to root g dt. And now I'll do the integration. Now you see that, you see this integration is totally different now. But how it is different, I'll show you that. अब एक बात बताओ बेटा, this y at the topmost point is length L or not, and here it is y or not. So the integration must be taken from where to where, length L to y. Are you able to get me or not? Concept समझ में आया? Okay, because see, if I am doing this integration dy by root y, what's the meaning of that? Basically, the topmost point, the velocity of wave starts, or the wave starts from the topmost point at the coordinate L. It's appearing at y finally. Its velocity is negative because it is downward. So the integration must be taken from L to y. And here also time t was 0 and it's meeting at time t. So the integration must be from 0 to t. Is that clear or not? So now write that equation. Root y integration is how much? If I do it, it will be appearing as 2 root under y. I'm writing it directly. Okay, to do the integration from L to y, sorry, and that is root under g into time period t. Are you able to get me or not? अरे मेरी बात समझ में आ रही है? Okay, now you replace the variables, you will see that it is minus 2 root under y minus 2 root under L is equal to root gt, है ना? माइनस को इसमें कन्वर्ट कर दो, 2 root L minus 2 root y, है ना, is equal to root under gt. ध्यान से देखो, 2 root under y is equal to gt. Put this equation over here, you will see that. Okay, so look over here, if I am just putting it, what I will get, 2 root under L is equal to root g, so 2 root under gt, isn't it? यही आ रहा ना, 2 कैंसिल, तो टाइम पीरियड मिला या नहीं मिला, कितना आया, रूट अंडर L by g. After what time they are going to meet? Root under L by g. Put that value over here in the equation of y and you are going to get the y also. So y will be equal to, okay, I'll use the straight lines, है ना? So y, if I just put it, it will be y is equal to, कितना आ रहा है, y is equal to, अगर मैं इधर पुट करूं तो रूट जी टी बाई 2 का होल स्क्वायर, यही होगा ना रिलेशन. So y is equal to, so t, if I put it a square, that becomes L by g itself, 2 square basically. So if we put in any equation, the answer will be still same. You see that? I'm just replacing because that's a substitution equation or not. So if I put t in this also and if I put it in this also, I'm going to get the same relation. Okay. So y will be equal to g, t is root under L by g. So this will be L by 4 g cancel. And at what height they are going to meet? L by 4. At what height they are going to meet? L by 4. Are you able to get me or not? मजा आया? अच्छा लगा ना क्वेश्चन? Yeah, it consists of too many equations. It consists of three different questions. Okay. So if I throw it from top or bottom, the answer is same. But when I throw it simultaneously from both top and bottom, the answer is different. Is that clear or not? ठीक है? Is that totally clear? Are you able to get me? Okay. So now give the heading. Energy calculation in the waves. energy calculation in the string wave. Okay. Now look over here. So we are basically, since what we observe, that here we are not defining mass as an independent term. We are defining mass per unit length, isn't it? You see that velocity was also defined as mass per unit length. Are you able to get me or not? So we are going to follow that part. We are going to follow that kind of understanding to define this whole thing with the mass per unit length. So basically the first task which we will do is defining the kinetic energy per unit length of the string wave. Okay, kinetic energy per unit length. Are you able to get me or not? Any kind of doubt till now? No. So let us suppose if we are defining kinetic energy per unit length. So you know that the wave equation or velocity or equation of wave is written as the original one, a sine, not the conventional one, kx minus omega t, isn't it? If I write omega t minus kx also, that is also fine, no problem with that. Is that clear? But since we are finding the kinetic energy, some kind of a formula based thing, so we will follow this a sine kx minus omega t. So whenever, see, remember that whenever if I say string wave, whenever I say string wave, you are going to use kx minus omega t. Which one you will use? Means whenever I am going to specify the wave, okay, whenever means there is nothing written, if it is saying the wave is moving like this, so you will say y is equal to a sine omega t minus kx. Are you able to get me or not? Yeah, if I'm saying a transverse wave which is moving along the right hand direction, then it will be a sine kx plus omega kx minus omega t. Okay. So if I have a string wave which is moving as, or a transverse wave moving as a is y is equal to a sin kx minus omega t, ठीक है, एक ट्रांसवर्स वेव है बेटा जो किधर की ओर चल रही है, राइट की तरफ किधर की ओर चल रही है, राइट. Then we know that this is the particular wave. So if I want to define the particle's velocity, then that is equal to dy by dt or not? Correct. So particles velocity will become how much? Minus a omega cos kx minus omega t. यही होगा ना, है ना? अच्छा, अब मेरे को निकालना है kinetic energy. What I want to find? So let us suppose if we have a string. One minute. Let us suppose if I have a string, okay, and I want to define the kinetic energy. So I can't define it for full length now because kinetic energy is variable, because the velocity of all the particles is also variable or not. So I'll consider a very small length which is have length dx, and as you know, since we are defining the mass of a string and all, so it has a mass. The string has mass, means what is given to you? Mass per unit length is given to you. What is given? Mass per unit length, which is exactly equal to how much? Mu. Are you able to get me or not? मेरी बातें समझ में आ रही हैं? अब ध्यान से देख, तो इस dx का means for this small reason I'll have a very small kinetic energy or not. I represent it by Dinesh Karthik dk, word or not? Okay, so the point is simple. This dk Dinesh Karthik will be half mass, means a small mass of this particular region, a small mass, into its velocity over how many particles are there, average velocity of that square, isn't it? So look over here, dk will be what? Dk will be half, dm is mu into length. Mu into length is how much? Length is dx, isn't it? And velocity of particle square will be a square omega square cos y square kx minus omega t. Are you able to get me? তুমি বুঝতে পারছি না? বুঝতে পারছি? চন্দ্রা, অর্থমাইন্দা? Yes, now I can learn. Huh? That is Telugu language. So I have a little language of Telugu, little language of Kannada, little language of Bengali, little language of Bhojpuri, good language of a little language of Hindi, little means good language of Hindi, good language means average language of English, average language of French, German, Spanish. I'm learning because I want to meet some good Spanish girls. Okay, so I got my the kinetic energy relation, like a small kinetic energy, which is half mu dx a square omega square cos square kx minus omega t. Are you able to get me or not? Are you able to get me? अब basically we call it as elementary kinetic energy. इसको क्या बोलते हैं बेटा? Why elementary kinetic energy? Because you see that this kinetic energy is associated with the element of the string or not? Is it associated with the full length of the string? No, it's only associated with the element. Are you able to get me or not? And you see that this kinetic energy is related with cos square kx minus omega t also. With what? Cos square. So cos is maximum for, basically cos is maximum. Cos theta is maximum for theta is equal to 0, isn't it? For cos is max for theta equal to how much? 0 degrees. Means if I have the initial phase to be 0, initial phase to be equal to how much? Means if the particular particle cos theta is equal to 0, that means what? This whole term will be equal to 0 or not? That is only when x is 0 and t is equal to 0. So look over here, we get the answer. ध्यान से देखने पर ये मालूम चलता है, means cos has a maximum value for 0. That means it is only possible, it is only possible when t is equal to 0 and x is equal to how much? 0. But t is equal to x is equal to 0 is my mean position or not? So when I have my kinetic energy to be maximum for any kind of a particle, when the particle is at mean position, when the particle is at, are you able to get me? Next thing, and you try to see that this cos value is minimum, means 0. This cos theta is minimum for theta is equal to 90 degrees or pi by 2. Are you able to get me or not? So that means basically when the phase shift, means you have to write kx minus omega t is equal to how much? Pi by 2. कितना रहना चाहिए बेटा? So when the phase is of pi by 2, क्या चीज के बराबर? Pi by 2, which is equal to kx minus omega t. For this value, I do not know what x value is there, what t value is there, but this is a point of maximum displacement. कैसा रहेगा? Maximum displacement ही रहेगा ना? Over there, we know that means extreme position if we define. So extreme position over here is defined at pi by 2. कहाँ पर defined है बेटा? Previously, the problem has occurred now in SHM. In SHM, so you look over there in SHM also. For SHM also, the extreme position is at pi by 2 or not. The graph bends. ध्यान से देखना जरा. The graph bends over here at pi by 2 or not. See that every pi by 2 it's getting bended. So that means what? Extreme position lies at pi by 2 also in SHM. So that's what it is saying. That when the phase reaches pi by 2, which is a point of maximum displacement, kinetic energy becomes minimum or 0. Equal to how much? Is that clear or not? So if I write this kinetic energy relation, which is, if I write this kinetic energy relation, this is my kinetic energy per unit particle, half mu into length mass into velocity is there na? Sorry, 1 minute. Velocity is a square omega square cos square kx minus omega t. Now this is my kinetic energy of the particle. But if I want to define kinetic energy per unit length, what I want to define? Kinetic energy per unit length. Then I need to divide this by dx or not. Per unit length must be equal to dk by dx, isn't it? Sorry, dk by dx. Are you able to get me or not? So what is that value then? Kinetic energy, I wrote it as KL only, that is dk by dx. Kinetic energy per unit length, that becomes equal to how much? Half mu a square omega square cos square kx minus omega t. Is that clear, guys? Chandra, is this clear? So this is defined as kinetic energy per unit length. Now try to understand, this kinetic energy is itself moving on this wave or not? Yes. So we define the rate of transmission of kinetic energy. Rate of transmission of kinetic energy will be what? If I want to define rate, that means it should be kinetic energy of the particle differentiated with respect to time or not. Correct. So if I differentiate with respect to time, what I will get it? dk by dt. If I differentiate, is it coming a square omega square also? If I differentiate with respect to time, what I am going to get? Tell me. Uh-huh. I'll get it as half mu dx by dt, isn't it? If I differentiate with respect to time, can I differentiate this with respect to time? I'll get some values, but that is of no use now, because that is just differentiating, making cube or something like that. Are you able to get me or not? Yeah, so we will just consider dx by dt a square omega square cos square kx minus omega t. Are you able to get me? We are not differentiating this second term. We are not differentiating this which term. Are you able to get me or not? Simple, because if you differentiate it cos square kx minus omega t, you'll get a term like 2 sine x minus 2 sine x 2 sine kx minus omega t cos kx minus omega t multiplied with omega. But once again, when you are writing 2 sine kx and all, it will once again it will be written as sine 2x and all. Is that clear or not? So that is of no use once again. Okay. Now, one of the most important thing is this cos square kx minus omega t is defined for the larger time. कैसे के लिए defined है बेटा? ये long time के लिए defined है ना? But what we are finding? We are finding the rate of transmission of kinetic energy for a short interval of time or not? Isn't it? So if I want to find the short interval time, then this must not be differentiated because this is defined for the whole period. Are you able to get me or not? Huh? See, this whole thing, this cos square kx minus omega t is defined for the whole big bunch of the time period or not. But if I want to differentiate, I need a short interval because this is dt I'm taking. So which is varying over here? Dx is varying over here or not? Means kinetic energy is varying with respect to position. So that's why I will take the differentiation of dx by dt. Are you able to get me? मेरी बातें समझ में आ रही हैं? Chandra, is this clear? See, the point is logical. I'm not taking this because this is defined for large intervals. Okay, is that clear or not? Now you got it. Okay, so tell me, any kind of problem? Yeah. So now you got the relation that this dk by dt is equal to 1 by 2 mu. अच्छा, this dx by dt is nothing but the velocity of wave or not? Which is how much? V. I'll call it as V into a square mu square. Sorry, omega square cos square kx minus omega t. You have to just remember this derivation. Okay, are you able to get me or not? So look over there. Let us understand this. What it says: dk by dt is equal to mu a square omega square velocity of wave and then cos square kx minus omega t. है ना? Are you able to get me? This is my whole term or not? So basically, what is this basically? This is, if I want to say, एक बात बताओ simple सा, that is my kinetic energy per unit time. ये क्या है? That is my rate of transmission of kinetic energy with respect to the length of a string. Are you able to get me or not? अरे कुछ तो बोलो हाँ या ना. अब एक बात बताओ, अगर हम ध्यान से देखें, अच्छा हम ध्यान से अगर देखते हैं तो इसको मल्टीप्लाई, यही दिक्कत आता है. ठीक है. अरे मतलब इसको हम डिफरेंशिएट करने जाएंगे ना लंबा वाला, तो ये चेन रूल को फॉलो करेगा. क्या फॉलो करेगा? चेन रूल को. ओके. हाँ, तो वो बहुत ही लंबा प्रोसेस हो जाएगा. सो दैट्स व्हाई वी आर इग्नोरिंग दैट फैक्ट आल्सो. ओके. So I got my dk by dt, which is called as rate of change of kinetic energy with respect to the length of string. But you only say me, this rate is defined as power or not? अरे कुछ तो बोलो. Kinetic and basically it is defined as what? Power. So power of wave is equal to, now since it is equal to kinetic energy divided by time, so that is equal to half mu a square omega square. But since we can cancel this 2 with respect to the differentiation with respect to chain rule, so it is just written as mu a square omega square velocity of wave. Are you able to get me or not? What is the power of wave? But this power, 1 minute, sorry, power of wave v into cos square, wait, cos square kx minus omega t. But where this 2 is gone, I'm saying that basically the 1 by 2, 1 by 2 is something called as a average rate. Okay, so I'm just not including this 1 by 2, because if I do the double, if I do that particular differentiation, this 2 can be cancelled out. And this power, since it is dependent upon time, is defined as instantaneous power. क्या बोलते बेटा? मेरी बातें समझ में आई या नहीं आई? Yeah, see, if I, okay, let me do that differentiation. No book has given that differentiation. Half mu dx a square omega. I'm just removing that. I'm considering, let us that okay, let us do it for half mu a square omega square dx cos square kx minus omega t. So what I'm doing is I'm just taking that, I'm just taking this whole part out and differentiating whole of this with respect to dt. So what I will get? Dx outside dt of cos square kx minus omega t, that is 2 cos differentiation is sine kx minus omega t, and that should be minus because it cos differentiation is minus sign, into cos kx minus omega t into another factor which will come as minus omega plus uh, cos square kx minus omega t into dt into dx by dt है ना. So what we are doing is we are just taking the instantaneous average. क्या निकाल रहे हैं हम? instantaneous average, when you will do that, you will see that this value over here is going to get neutralized 0, and I need to divide this whole term with respect to, sorry, I need to divide, I do not need to divide. Basically this appears as 4 cos square or something like that. So अगर हम instantaneous average निकालते हैं तो almost we ignore this fact and we just include this term. Are you able to get me or not? Okay, is that clear? The reason for this is, if you do that average thing now, you will see that this sine and cos, if they are independent, they become almost equal to 0. कितने बन जाते हैं वो? 0. Okay, ठीक है, तो वो 12th में तुम सीखोगे. But the point is, we just remove. अच्छा, एक काम करना, I'll tell you how to remove this 2 2. That's not required in your syllabus right now. Okay. Okay, let us just remove this 2 right now for the time being. Okay. Then I'll tell you how come I can tell you. Wait. You want to go. Okay, let me derive this. आ जाओ, देखो कैसे 2 जाता है बेटा. इतना अच्छा, इतना दूर समझ में आया कि नहीं आया? पहले ये दो. That kinetic energy is equal to half mu VA square omega square cos square kx minus omega t, and that is rate of transfer of kinetic energy. Got it or not? Now I'll define this for the power case. I'm going to directly define for the power. Got it or not? अच्छा, एक बात बताओ. We know that y is equal to a sin omega t minus kx or kx minus omega t, है ना? Whichever thing you want to follow. Should I use omega t minus kx or kx minus omega t? What do you want me to follow? Okay, so let us follow the general one. And then dy by dt is my velocity of the particle, isn't it? How much is that? A omega minus a omega cos omega t minus kx. यही है ना मेरा general equation of velocity of particle. अच्छा, एक बात बताओ बेटा, even I can define dy by dx or not? What is that? dy by dx will be what? A k. This is not going to be minus. Sorry, this will be not minus over here. This will be minus a k cos ओमेगा टी माइनस के एक्स. बोल बेटा, हाँ या ना, यही होगा ना? इज दिस क्लियर और नॉट? अच्छा, अब एक बात बताओ. whenever a wave is moving whenever a wave is moving, the thread will be like this way or not? Thread will be, 1 minute, the thread will be something like this way, isn't it? अरे कुछ तो बोलो हाँ या ना. And over here the tension T will be present. This is my tension T or not? Now try to see this tension T. This tension T creates, let's suppose if I am considering, 1 minute, let's suppose if this is my horizontal level of tension T and this angle is theta. Okay, that angle is how much? Theta. So see that I have two components over here. One is T cos theta, है कि नहीं? तो कुछ तो बोलो. Another one is T sin theta, isn't it? One is T sin theta, another one is T cos theta. So if I want to define power over here, what I want to define? Power. So you know that power is equal to force dot velocity vector or not? Instantaneous power is what? F vector dot velocity vector. So which tension is actually trying to pull it downwards? T sin theta. Force dot velocity, that is Fs cos theta. Are you able to get me or not? Velocity, if you see the velocity of the particle moves up and down or not? Over here on this SSM axis. So basically, which force is making it move? T sin theta, and that is multiplied with the velocity. That must be equal that must be taken as negative or not, because when the velocity of the particle is upwards, tension is downwards. Are you able to get me? Now, if I multiply velocity of the particle, what I will get? I'll get this relation T sine theta. Velocity of particle is A omega cos omega t minus kx. Is that clear? मेरी बातें समझ में आई? Are you able to get me? Now, as since these thetas are small. So basically, this if this theta is small, so I can write sine theta as also similar to dy by dx or not. Perpendicular by base, कुछ तो बोलो हाँ या ना. So what I get, t into sine theta is dy by dx. Dy by dx right now we calculated. Sorry, this is multiplied with the minus. Now minus minus will be plus. A k uh, a k cos omega t, इसका भी cos omega t. So a k into a omega cos square omega t minus kx. यही रिलेशन आएगा ना बेटा? That is my instantaneous power, isn't it? Now, if I define instantaneous power, tension T is what? You know that velocity of wave is equal to root under T by mu. So what is tension T? Simple. Velocity of wave is square into mu a square k omega into cos square omega t minus kx. यही रिलेशन है ना? और ओमेगा k होता क्या है? Basically k is what? Omega by k. So instantaneous power is omega by velocity. Sorry. So velocity cancel. I will use k as, if I use k as, so velocity of omega square mu a square v by omega cos square omega t minus kx. Sorry, what I have written, omega by v, omega by v. So v and v got cancelled. So therefore we got the relation of instantaneous power, and that is exactly equal to mu amplitude square omega square velocity of wave into cos square omega t minus kx. Now you got the idea or not? That's what is called as rate of change of kinetic energy or not? And this is what is called as rate of change of kinetic energy, which we also define it as power of the wave. Are you able to get me or not? मेरी बातें समझ में आई या नहीं आई? Yeah. Which one? This one. This one. No, no. See. Sine theta. Basically, sine theta is similar to tan theta if theta is small or not. But that can be written as what? Dy by dx. Velocity, the SHM equation of the particle wave is a sine omega t minus kx. So if I do the dy by dx, I get this term. So I just multiplied this over here in this step. Okay. Omega t minus kx. Huh. 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 Simple. Basically, you tell me only velocity of wave is equal to root under t by mu for a stretched string or not. We are doing for the stretched string, isn't it? So that's why I replaced t is equal to v square wave into mu. Got it. And k, the particular wave number is written as omega by v. That's what I replaced over here. So that's my instantaneous power. Now, basically, since this is related with cos square omega, instantaneous power is related as what it is written as mu a square omega square velocity of wave into cos square omega t minus kx. ये है. Now, if I want to find the average power, this power is varying with respect to position and time. So if I find the average power, so average power, I have to take the average of this value or not? Cos square omega t minus kx. Are you able to get me? So average power of this, the average power means if you take the average of this value, it is exactly equal to how much? 1 by 2. How much it is? 1 by 2. That comes from integration. That I will not do that derivation right now. So just remember it. Anything, average of cos square x is 1 by 2. Average of sin square x is 1 by 2 also. Are you able to get me or not? That you will learn in class 12 definitely. So that is equal to 1 by 2 mu a square omega square velocity of wave. So this is my average power of the wave on the string. Are you able to get me or not? Now you got the idea how I wrote this relation, that rate of change of kinetic energy is half mu square. Now you got the idea. So power of wave is instantaneous power, but the average power is exactly equal to half of instantaneous power, which is half of mu a square omega square velocity of wave. Are you able to get me or not? है कि नहीं? अच्छा, अब बहुत लोग इसको velocity of wave को कैसे, you know that omega can be written as also 2 pi f, frequency into time period, isn't it? Sorry, omega can be written as 2 pi f also or not? So that becomes what? Mu a square. This the relation which appears for the average power is twice mu pi square a square velocity of wave square. This is called as instantaneous power. Sorry, average power of the string wave. Are you able to get me or not? Understood? Did you got the idea? So this is what is called as energy of the wave is defined for the what? Kinetic energy per unit length, and that is given as half mu a square omega square cos square kx minus omega t or omega t minus kx, whichever you want to do. The rate of transmission of power is exactly equal to half of the power of the wave. Okay, and average power is also equal to half of the instantaneous power of the wave. Are you able to get me or not? Is this clear? है ना? So we'll do some questions related to that. Tomorrow we will do reflection, reflection and transmission of the waves, and then we will move to standing waves and the next topic. Is that clear? Okay, so till that we'll meet tomorrow once again. Let us see 9 p.m. itself, and then we'll finish this topic. Okay.